Okay, ladies and gentlemen, now let's go the other way. Instead of assuming that we have parallelograms and going somewhere else and proving the little pieces, what we're having is we're given the little pieces and we need to prove that it's a parallelogram. Now, folks, let's go back and let's remember one thing that's important. The only way to prove is using the definition. And the definition means we need two sets of parallel sides. All right, we need two sets of parallel sides. The only way to get sides parallel is to get angles. So we're basically going to go from givens. We're going to use our theorems. We're going to prove angles. Then we're going to prove lines parallel, and that proves parallelogram. Okay, so givens to the theorems to prove angles, to prove lines parallel, to prove parallelograms. Now, we're given opposite sides congruent in this case. Well, the nice thing is if opposite sides are congruent, I can draw a diagonal, and it's congruent to itself. So these two triangles are triangles congruent to triangle by side, side, side. Then I can say this angle to this angle. Angle is congruent to angle by CPCTC. This angle over here is congruent to this angle over here by CPCTC. So we used our givens, used a couple theorems, side, 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 to prove some angles, CPCTC. Now, I know that if this angle is congruent to this angle, that BC is parallel to AD by alternate interior angles, because if the angles are congruent, the lines are parallel. I can also turn it this way and say, if this angle and this angle are congruent, that means this line and this line are parallel. So I can say AB is parallel to DC by alternate interior angles. As soon as I get set number 1 and set number 2 of parallel lines, I can say, not triangle, that quadrilateral ABCD is a parallelogram by definition of parallelogram. Okay, by definition of parallelogram. So again, givens, theorems, prove some angles, prove some lines parallel, now it's a parallelogram. Okay, if on the other hand, I have the following. I have the parallelogram. A, B, C, D, this is theorem 610. And I know opposite angles are congruent. If opposite angles are congruent, that means this is congruent to this is congruent to this. Well, wait a minute. I can basically work this theorem right over here backwards and say, if these two are congruent, that means these two are supplementary. If these two are supplementary, then I can prove this line and this line by consecutive angles, and this line and this line by consecutive angles. And so once I have that AB is parallel to DC and AD is parallel to BC by consecutive angles, okay, I can say that the shape ABCD is a parallelogram by definition. You'll notice I keep proving by definition. All right, now, again, let's go down to theorem 611. This says if the diagonals, whoa, that's a horrible diagonal. If diagonals bisect each other, then it's a parallelogram. Well, this is congruent to itself by vertical angles. And so now A, B, C, D, E, I can say triangle ABE congruent to triangle CDE by side angle side. And if that's true, then this angle has to be congruent to this angle. Angle congruent to angle by CPCTC. So this line is parallel to this line. AB parallel to CD by alternate interior angles. And that means this is congruent. Oh, there we go. Let's make them different. This is congruent to this, again, CPCTC. So AD is parallel to BC by alternate interior angles. And now I can say this, ABCD is parallelogram. So we'll just parallelogram. Okay, so that's what we're doing. We're just going back and forth and we're proving them back, and it's by definition of parallelogram. So use that information to solve the rest of the problems.